So we have a large number of asteroids of varying sizes orbiting the Sun in the asteroid belt. What actually are they made from? Well, just like there are different sizes of asteroid, also different types of asteroid. Like the inner rocky planets, none of these asteroids are purely one type of substance. Instead, they're a conglomeration of different elements and materials built up over time. However, these asteroids are actually divided into three main groups: metallic, carbon, and silicon, though there are more specific subtypes within those groups. Metallic asteroids are generally found in the middle zone of the asteroid belt, mostly iron, with smaller portions of things like nickel and other metals like gold, platinum, and iridium, and other precious metals. And it's these that proposed asteroid miners are likely to target to extract the rare metallic elements, which are many times more common in these asteroids than they are in the Earth's crust. The carbon asteroids are by far the most common form of asteroids and form in the group which are furthest out from the Sun. Probably the oldest of the asteroids. These are made from carbon along with silicon and other minerals. They're normally made up from fine grains of material which stuck together to form a rocky or a clay-like structure. Presents a high proportion of carbon, along with the fact that these structures formed at a substantial distance from the Sun, meaning these asteroids are darker than the others and hence more difficult to spot. Finally, the silicon asteroids are found in the inner part of the asteroid belt. These tend to be a combination of silicon and iron with some magnesium or nickel. These are far harder and rockier asteroids than the carbon asteroids. They're also brighter and shinier like the metallic asteroids. Then we have more asteroids which are similar to the carbon asteroids, found slightly further out than the asteroid belt. These are orbiting the Sun at approximately the same distance as Jupiter, and they're known as the Trojans. Now, planets other than Jupiter have Trojan asteroids associated with their orbit, but Jupiter has by far the greatest number of them. As Jupiter orbits the Sun, there are other asteroids travelling at the same speed in the same direction on virtually the same orbital path as Jupiter. However, these asteroids are not randomly scattered about the orbit of Jupiter. Instead, they're concentrated in two distinct zones or swarms, one 60 degrees ahead of the orbital path and one 60 degrees behind the orbital path of Jupiter. The swarm of the asteroids ahead of the orbital path of Jupiter are known as the Greeks, and ones behind the orbital path known as the Trojans, though collectively they're just known as the Trojans. The total number and mass of these Trojans may be similar to the numbers in the asteroid belt itself. In general, likely have more ice in them, especially in the core, than standard carbon asteroids, and they're not quite as dark as those carbon asteroids. Now, like the other asteroids, these Trojans have to contend with both the gravitational pull of Jupiter and the Sun. This is where the three-body problem comes in. The gravitational pull of two very large bodies, how can a small body like an asteroid maintain a stable orbit? Well, it turns out there are 5 areas calculated by Joseph Louis Lagrange. That's where he thought this was possible. Now, 3 of these areas are very small areas and are on the surface fairly logical locations. The first 2 areas are either slightly inside the orbit of Jupiter or slightly outside of the orbit of Jupiter. That way, the Jupiter and the Sun and the asteroid are in a direct line. Now, the third area is on the opposite side of the orbit of Jupiter, again meaning that the Jupiter, the asteroid, and the Sun are in a direct line, minimizing any gravitational distortion. Now, the final areas are much larger and on the surface just a little bit odd. Now, if you attempt to draw an equilateral triangle with the Sun at one corner and Jupiter at the other, and the orbital path of Jupiter for the third, there are 2 possibilities: 60 degrees ahead of Jupiter's orbit or 60 degrees behind it. It's where basically the force pulls the direction along the sides of the triangle, keeping all 3 objects approximately in their relative places. These are the regions where the vast majority of Jupiter's asteroids, known as the Trojans, can be found.